dev4. Scrolling. That took the wind from my sails. Okay. What we're going to do today is we're going to see, first of all, an introduction to the course and general idea of examination, expected study load, etc. Then I'll give an introduction to design patterns themselves. Then we'll see a specific design pattern, which is the visitor design pattern, applied to the option data type that we've seen at the end of last video. Also we see the adapter design pattern, but it's just going to be implicit for a moment. So we're actually going to see 3 design patterns. Then we'll discuss the course agenda very briefly and close out the lecture. So first of all, the burning questions. How is this going to be examined? No surprise here. You get an exam, which is go or no go, based on a grade of at least 75%. You get 3 open questions this time, just to add some variation, you know, to make it spiffy. You get a question on. I don't feel the love and enthusiasm. I mean, imagine if it, yes. Imagine if it changed every course. I mean, come on, it can always be worse. Remember. Yes. Anyway, then you get the question on the type system. So we code that has heavily to do with design patterns. So basically, tell us how it works at runtime and how it works at compile time, and then upon big request from students, we got sorry.
I thought I see UML.
UML. You get a question on UML. So you get the design pattern of a UML, the UML on design pattern. We should take care of the fact that you learn to write UML. You get UML, and we say this is the visitor pattern, and you have to fill in the missing methods. That's it. Oh, come on, people. That's like a free question. That's like 25% of the grade is for free. You have to draw boxes.
Draw boxes. You can follow that.
Yeah. Besides a few lines. Now, then you get a bunch of exercises that you will find on GitHub. The exercises are not mandatory, in the same way as, I don't know, looking before crossing the road in Feyenoord is not mandatory. Don't do it, you're stupid. And you're gonna eat the early 40. So, these are design patterns in isolation. So you just build small design patterns by themselves, and that's it. Then you have the assignments, which are, and I think this is an awesome assignment actually, building a GUI framework, like Windows Forms or Java FX, from scratch by means of design patterns. You're not going to build the full framework because that would be uninteresting, but you're going to build the basic structure and make it general purpose. Because as you have realized now, GUI frameworks are something where you expect to be able to, for example, put a button or a label or a text box, whatever, inside the form, and it just has to work. So we're going to get to this behavior. This is mandatory. You don't get a grade for this because the grade you get from an oral check. Yes, in the oral check we give you a working solution with a bunch of pieces missing, and you fill it in. Now, yeah, you do know how this works. The oral gives you the final grade for the course. Now, you've seen this slide already. 10 to 20 hours a week study effort. You don't do it, you don't pass the course. I do. Also 10 is fine. 20 to yes, then you pass the course and you pass also the next course. Just like that. Yes. Once again, just because the slides are in your physical vicinity or somewhere on the screen does not mean you're studying them, okay? If you print the slides, put them under your pillow and sleep on them, it doesn't count as studying, okay? You got to fully focused attention for 10-20 hours a week, okay? Good. If you don't understand every single term and every single sample and you don't try it out in your machine, or it doesn't work, or you don't understand why it works, ask one of us, or Google, or brainstorm with other students. Okay? Now, back to the course. What have we seen so far? We've seen a lot of machinery. But most of the machinery we've seen, like functions, recursive functions, data structures, classes, encapsulation, polymorphism, subtyping, generics, etc., we have discussed how to use it properly. One realization that might have dawned upon you is that all of these things are ways to express and define interactions between entities. So they're glue. They're ways to do glue. Think about an if, then else. What does an if and else glue together?
A choice? No,
Yes, it glues three things together actually.
problem answer.
Kind of. What three things does an if and else glue together?
Let's do it together.
Aan elkaar vastlijmen.
Anyone?
It's a predicate of two cases.
A predicate and two cases. It glues them together. And now they're one thing, the if then else. You have the condition, then and else. They're glued together. Now they interact with each other. They do something together instead of in isolation. Classes are a way to glue together a bunch of methods and a bunch of fields. Inheritance and subtyping are a way to glue together a bunch of classes, and so on. So these are all ways to express interactions among entities, and the more we move upon in these layers, in this pyramid of abstraction, the more we can write a bit of code and have it interact with lots of other pieces of code. The problem with interactions is that interactions between entities do affect maintainability in a negative way. The more interactions we have, the higher the likelihood is of having bugs. And this phenomenon is known as coupling. Coupling is the idea that you change something in a program and something else must be changed accordingly. And this is coupling. Coupling is a form of binding of entities in a program. High coupling is undesirable. Low coupling is our goal. The goal of this course is to reduce coupling between entities. High coupling happens when the number of interactions between classes A and B, so you have two classes A and B and they interact a lot. They know each other a lot. They have lots of interactions, so they're highly coupled. And this translates into something that you should have experience with. So A and B are fine. Okay, B especially is fine. Then you change A, and now B breaks. Ever seen this? Who has seen this? Raise your hand.
Amateurs. Maybe dat is it.
And is it a fun process? So you fix something in A, and now B breaks. It's like a short blanket, you know? Now your feet are cold, and you turn around, your back is cold, etc. It's a short blanket, and we want to make the blanket bigger. So, an example of high coupling. Suppose we have a driver with a car. And the driver, when he wants to drive, says this.car.move. The car has the move method, but also the cylinders. You know the cylinders? What they are?
Ja, tuurlijk.
The what?
Wow, joh. Heb je geen auto in Aruba?
It's also perhaps not the best jazz driver. the alternative. So anyway, the point is, the cylinders are not relevant for the driver. Because the driver just interacts with the move method, with the steering wheel, with the accelerator. Yes?
Maar heb je niet op private gezet dan?
Because the
Dat is niet belangrijk.
because the mechanic might actually need to muck around the cylinders.
Maar,
And they're broken, or you want to have a faster car.
ja,
You know?
oké. Maar dan alsnog kun je het op private zetten.
But then the mechanic can like access it.
Ja, je hebt er een sterke fix.
Yeah, then it's public. So, the number of interactions between two classes A and B is what we're gonna try to achieve is the number of interactions between two classes A and B limited to a series of methods provided by an interface. So we try to put an intermediary, which is an interface that mediates the interactions.
I had a question about the previous slide on line 4. What is this?
Ja, public dus.
That is probably a typo. And a weird one as well. Now, thanks. So, what we do now is that the class driver will now interact not directly with the car, but with an interface, a polymorphic type, vehicle. So now, if you look at the line 2, you notice it takes longer than line 3. So the driver interacts with a vehicle, not a car. And the car implements vehicle, but now the driver cannot see the cylinders. And is this a good thing?
Yes.
Why is it a good thing?
You limit options.
We limit options to break things, and you want as little options to break things as possible. Because remember, the other people in your team of developers are your enemies, and you don't want to give them weapons. Okay? So this is giving them less weapons. Moreover, this is inserting flexibility, because doesn't electric car have cylinders? No, it has magnets and coils. So,
En een grote accu.
and gigantic output typically underneath, yes. So now, if we want to give the driver an electric car, we can, because we don't have the strong coupling between the two things. If we want the driver to be an old lady driving a Nike Subbrommer, you know, the ones that are limited to 45 kilometers an hour, then it's fine as well. So this is more flexible, and we have less ways to break things. Yes?
Do we learn low coupling by, or do we learn to use low coupling by like a set of rules that we just need to
No.
learn, or by?
There exists no set of rules here. In the whole 4 years, anyone that sells you a set of rules is not really. I'm not going to comment on that, but no rules.
Meneer, camera staat aan, hè?
Yes, exactly. So I stopped at the right moment. Point is, there are no rules because the number of reasonable programs that you might write is not only infinite, but it blows up exponentially. So there is no rules that tell you have this problem, this is the recipe, these are the steps, and this is the solution. There exists no such thing. There really doesn't exist such thing.
So it's just experience.
And intelligence. Intelligence gets you a long way. Now, as the number of entities in your program, imagine classes, packages, etc., increases, the number of interactions between them increases exponentially. No, faster than exponentially, actually. More precisely, given n classes, the number of interactions is this. Doesn't matter that's what that means, but you know the explanation. Yes, but you know the explanation, the exclamation mark. That's not a surprise indication, but it's a facultative, it's a factorial. And the factorial of a number is a very big number for a small input. What is, even for classes, then the number of interactions between groups of up to the 4 classes blows up to 30 for 4 classes. For 50 classes, it blows up to billions. For 150 classes, it's one of those numbers like number of grains of sand in a beach and so on. So, it's huge. The number of possible interactions, if everything can talk with everything else, is simply too big. There are 2 possible paths that break things.
Where did you get that number? Like, and where did you get that formula? Is there
The
a
formula?
source for it?
By just doing basic combinatorics.
Okay.
We can talk about this later if you want, but more privately. Also, it is an old formula, but from combinatorics. Now, the goal of achieving low coupling is to reduce the number of possible interactions. So that gigantic number, make it small. Low coupling will result in easily maintainable code, and this seems desirable, as it will reduce the cost of fixing bugs and the cost of changing functionalities. Now, we will control interactions by always. Now, this is a rule. This is a rule. Anytime 2 things need to talk to each other, we put a mediating interface between them to make sure that we can decide and control along which ways they can interact. So, suppose we have a driver, and suppose we have the vehicle. The vehicle is the mediating interface, and the interface acts as the gatekeeper between the driver and all possible manners of vehicles. Got it? So there's, how many possible vehicles exist?
Infinite.
Infinite. And can you, and the point is, you don't even know which ones are relevant for your application until you've actually tried it, you've spoken with customers, etc. So not only is this a big set, it's infinite, but the actual vehicles that you implement in practice is going to change as you talk with customers. So this is a big set and constantly changing in your implementation. So we put a gatekeeper in front of this set. We never touch the set directly. Whenever the driver wants to talk with a car, it does so by means of the vehicle gatekeeper. On the other side, for the car, the vehicle is one of the roles the car can fill in. So this is also in the other direction. The car fills in a bunch of roles, and the roles that the car fills in are the interfaces it implements. Now, the general view of load coupling is that given two classes A and B, class A wants to talk with B, but it doesn't do so directly. It does so by use of the IB interface of B. And if B wants to interact with A, it does so by going through the interface IA. Or, in UML, what this means is that,
Meneer, is die toets ook zo?
who knows? It
Wat is
could
dat,
be.
meneer? Abstracte vraag.
It could be.
Ik vraag u een specifieke vraag, ik geef een abstract antwoord.
No, I gave a precise answer, which is perhaps. Now, A wants to talk to B. So what A actually does is it talks to IB. But IB implements B, so actually A and B are talking to each other by means of this double step. And B can talk to A by means of this other double step. Got it? Good. Now, in this example, the driver, vehicle, and car, you could imagine that the driver is class A, the vehicle is class B, and the interface vehicle is class IB. And the car talks with the interface by implementing it, that's line 10 here, and the driver talks with the car by means of going through the vehicle, and that's line 2 and 4. Yes? Should the car also need to know something about the driver, then we would probably have an interface driver here that the concrete driver, the driver person, would implement, and then the vehicle would have a reference to the driver, because the driver might also become an artificial intelligence eventually, in a Tesla, for example. So you might also want to mediate that. Interactions, like the one we've seen above, happen to be disciplined, happen to be clean. And these interactions tend to exhibit some recurring high-level structures. Now, the proper recurring high-level structures do nowadays take the name of category theory. So the patterns, the design patterns of design patterns is a field called category theory, which makes category theory much simpler, but it's not that simple itself. But these recurring high-level structures, if you just take them as a broader collection and just list them, they fall under the nomer of design patterns. Design patterns are, in short, then, ways to capture recurring patterns for expressing controlled interactions between entities. And we will now see a specific example of such a pattern. So here's our first design pattern. I have a 5-year-old daughter, and she has a book like our first coloring book, so I decided to use that same theme here. Now, as you already know, polymorphism is a powerful mechanism that allows decomposition and code reuse. But sometimes we have a general instance of something like the animal class, and we want to do something concrete to it. One case is a cat. So suppose you're in Venice, okay? And you have a cat at home. But in Venice, unfortunately, in the canals, rats are known to swim. And by rats, I mean things like this, plus the tail. Okay? So, if you find an animal in your living room, okay, you need to say it's an animal, because it might be a rat or a cat. But if it's a rat, you're not going to want to feed it. You're gonna go pick your flamethrower up. Or just burn the house down. It's a viable and well-known response. If it's your cat, you might pet it, you might cuddle with it if it's winter, you might feed it, whatever. Okay? You're not gonna try to cuddle a rat. Obviously, it's gonna bite your hand off. So, what What is sometimes we have something like an animal and we want to temporarily, just for a moment, for a brief check, go back to concrete instances. Now, suppose similarly you have a vehicle, and yeah, the vehicle might be a car or a bike, and you want to use the vehicle to go to work. And if it's summer, you might want to, it's still a vehicle and you're still going to drive it, but for a moment as you step in the vehicle you might check, is this a car or is this a bike? And if it's warm, if it's a car, you turn the airco on. And you can't say that the vehicle has a method like turn airco on, because what kind of implementation can you give to a method like turn airco for the bike? Does your bike have air conditioning?
Free air. Oh, you're in the open air.
Yeah, but if it's summer, then you know what I mean. So, what we want is to build a mechanism that allows us to manipulate polymorphic instances like animal or vehicle temporarily, so just for a brief moment, as if they were concrete. And these concrete instances are the only ones that know their identity. So we allow the concrete instances, based on their identity, to choose the proper option among a series of options. Like, if you're the car, this is the first option. If you're the bike, this is the second option. If you're bus, this is the third option, and so on. So, let's build the visitor design pattern. Let's apply this to options. First of all, a short recap on the option data structure. Do you remember it from the last lecture? Who remembers it? Now, everyone else that didn't raise your hand now. Now? Yes? You suck. So, seriously, it's a lecture. I put it there. I've done it with love. There are samples of code online on GitHub. Anyway, the I option of T data structure is used when we might have a value of type T or not. That is not valuable. That's available. And this is also a design pattern. It's a very simple one, which is called the ratify null or null object, which is a way to have something that doesn't contain data, but is not null. Have you ever had a null reference exception? Yes? Would you like to never have it anymore in your life? Never ever make it mathematically impossible? Would you like it? Yes? No? Yes? Everyone would like? That's how we do it. With the I option. That's important. So I emphasize that it's important. Really, you have to learn to use this. Now, I prefer to program this because it brings a bit of life into the process. I'm gonna skip the slides, but yes?
Van dit staat er op camera. Dan komt FBI, politie binnen en nemen ze mee en zo.
Let them come. So, oh look, I have Java in Visual Studio.
Meneer, gebeurt het 2010?
No, this is 2015.
Maar die thema lijkt daarop toch?
Unrelated. Does anyone know how I can remove buttons from the Visual Studio menu? Now, come on. Yes. Okay. So let's begin by defining interface I option. I'm going to call it I op because it's shorter. Okay? And this begins empty. What I want to do is now give two implementations of the interface I option. One for the case of no data of type T available, and one for the case of one value of type T available. So, les none. Is none going to contain data? From the name? No, it isn't. Then class sum, which contains a value of type T, and the sum has a private value of type T, and a constructor sum that takes TV and initializes this.value to T. Okay?
Meneer,
Yes.
waarom zie je voor het gemak even direct public?
No, because I'll show it. But this here is internal. You may not access this because what you're going to be given is an IO. Better?
Yes.
Okay. Now, let's define an I option of int. We will read from the console a string as console.readLine, and then we try to parse it as an integer. So if int.tryParse, what's wrong with it? Oh, okay. String s on value I, then string s was a properly formatted integer. Otherwise, string s was something else, was garbage. Oh, yes. Now, if we're here in line 35, did s contain an integer?
Yes.
Yes, that's reasonable to assume. So we put into my int new sum of int containing the integer I. Otherwise, what do we put here? What do you think?
No.
None. We put none. None of int. Now, what do we know about my int at line 40? First of all, if the user did not put an integer in a console, is my int going to be none? Going to be null?
It's an IO.
It's an IO, yes. But is it ever going to be null?
No.
No. Was it possible for int to be null? Can int be null? No. So we make it possible for to say I have perhaps an int. Now a better name for this might be perhaps or maybe. You want me to call it maybe?
Mm-hmm.
Really? You want me to call it maybe? Shall I call it maybe? I'll call it maybe. I call it shorter maybe. We save keystrokes. Okay? Now, on line 40, what we know about my int is that it might be sum with an integer inside, or it might be none.
Natuurlijk van boven veranderen.
It's done automatically by the patch, by the awesome power of Visual Studio.
Net zo pervloed.
So, now the problem is that here, what do we have available in my int? Do we have the value? No. And why don't we have the value?
Because it's not implemented
Where?
in the interface.
Yes, and why can't we implement it in the interface?
Because there is nothing.
In which? Where?
In the if.
Suppose,
None doesn't have value.
yes, none does not have a value. So even if I said here, t get value, what implementation of get value would I give in none?
It's
Return.
there.
I'm looking at someone with intensity.
I know.
No, you do know. Come on. Can I implement get value into none? I have to return a t. Which t do I return? In line 16.
No.
Sorry?
No.
Are you sure?
I don't know.
If t is an integer, can you return null?
Back to test and goes on it. Dat is een goeie.
You can do it's empty.
You can't implement get value in none because you don't have a t to return. In some, yeah, you have t value, so you have a t to return, but in none, you do not. Do you understand this? Okay.
Dat is logisch dus. 1 plus 1 is 2.
Yes, exactly. And if you don't have a t, you can't return a t.
Anders leven 7.
Yes. Good. Now, moving on, because this we've seen. So, let's build a way to safely access the value inside an option, if there is such a value. We add a method visit to the interface. And this method visit accepts a visitor, which we call iOptionVisitor of t, the type of the option, and u, the result of the visit, which we leave open. The visitor object will be able, we're missing a b here, will be able to identify the concrete type of the option, whether it be some or none, and manipulate it accordingly. Now notice that in the literature, the visit method is also called accept. So the interface iOption will be extended by having a visit method that accepts an iOptionVisitor of the EU. Okay? Now, the iOptionVisitor has only two methods, onSum and onNone. When is onNone going to be called?
If it's none.
Inside the option when it's none. And this is brain dead. When is onSum going to be called? When it's sum. And notice that onSum takes as input a value of type t. Where is this going to come from?
From the air. It's magic.
No, it isn't.
From
There is
sum?
no magic in this. Yes?
From sum?
From the sum, because sum has a value of type t. And this is going to be called when the option is sum. So we have a value of type t. Yes? No? Yes? Good. So we now change, oh yeah, now an implementation of a visitor that visits an int option and turns the internal int into a string has the two methods, on none, which returns I'm none, and on sum, which takes the value of type int and returns value equal to string. This is just a printer. Now, none has an implementation of the visit method that gets a visitor, and visitor has two methods, on none and on sum. Which one are we going to call here? On none, obviously, because none knows that it's none, so it says, yo, visitor, I'm none. Yeah, this is yo, visitor, I'm none. Can you see it? Good. Then, the sum gets the visitor and says, animate this please.
Your visitor, I'm sorry.
And this is my shit. Okay? Right? Good. So, when we visit, we simply give an I option visitor to the visit method. But I'm going to program this so it's clear. Now, let's define an interface, maybe visitor, tu, with two methods. U on none, takes no parameters. Why does it take no parameters again?
Because it's null.
Because it's
None.
none, so there is no t to give, right? The lecture would be much more funny if we said if this was a d. On sum, takes as input a parameter of type t, because we have a t to give here. Now, the maybe takes as input a visit parameter, which is generic in the type u, and visit accepts a maybe visitor of t u visitor. Now let's take a break for a second. Why do I declare that the method has a generic parameter? Why is the u declared in line 17 and not in line 15?
Because we don't want to give it. Obviously.
Yes, but why? Why don't we want to say that this is maybe, so the maybe of t means that this is either no t or 1t, right? But u is the result of the visit. So does this have to be fixed?
No.
No, it doesn't. That's the point. So every visit might produce a different u. So suppose this were integer, okay? The visit might produce another integer, which is 0 if there was nothing, or the integer plus 1 if we had an integer, or u might be a string, because we might want to convert the int to an integer to the string description, or just a string that says there was no integer here. Okay? U might also be another maybe of something else. U might be a network connection if this was an IP address. So U might be anything we might want it to be, and it might change during the visit. Yes?
Where do we declare you?
There.
Online? Or
17.
oh,
And it goes here.
oh
This
yeah,
here
I get it.
is the declaration of the U.
Yeah.
And the declaration of a generic type is always between the angle brackets. Okay? In Java, the declaration of the generic type is here. Java is also a beautiful language. I'm not going to say bad things about Java on camera. Now, so let's implement visit. This is none, so what are we going to call? Sorry? I'm none. On none. And then here, we are going to call.
Visitor on some.
That's it.
Isn't there still a
With
risk
the-
that you can call on some if you're not paying attention to what you're writing in the num?
No, because then you can't give a parameter.
Why not? You could give a string or whatever.
Haha, we're going to try that. First of all, what value do we give here?
Value.
Please not value. No. So let's try to call on sum here.
Ga je toch chillen met ons.
What t are we going to give here?
Nope.
What do you think?
Try giving it something new.
Something new?
Yeah, like.
But we don't have any constructor on t. So I can't say new t.
No,
because-
but can you give it just put a string there? Why isn't that valid?
Because it's t. Because this is a definition generic in t, and so we can't accept it. Because it's forcing t to be a string, but this is a definition that's generic for that has to be valid for all t's. So this has to be on none. Now the only risk would be to call on none here and ignoring the value. This is a mistake that you can make.
Nee.
Yes.
Microsoft heeft zo beautiful sterke ding gemaakt, editor. Hij kan dat niet eruit filteren, als je geen mistakes maakt.
It was over that.
Could you provide
No, but this is a semantic error. This is a logical error. So this would be valid code, just stupid. But stupid cannot be prevented. I mean, every time you build a better tool to prevent stupidity, the universe makes a better stupid person that's gonna break it in new ways.
Okay.
Could you give null in the unsum?
Also not, because t might be an integer which doesn't support now. This is reasonably tight. Now, at this point, let's build a visitor. So printer, int printer, that implements maybe visitor from int to string. And on none, we'll return, well, there was no integer, so this makes us sad. And on sum, we'll return a happy face,
En oh yeah, dat mag toch.
follow, sorry?
Oh yeah.
Anyway, it's fine. Now, the smile followed by the integer. At this point, we have the integer, so we could say console.writeLine my int dot visit, and here we give the visitor and we give the int printer. Okay?
Is toString a safe function? Just
Yes.
okay.
ToString is guaranteed to be there on any instance. So let's put some garbage. Get a sad face. Ah, poor surface.
Good job.
Then we put 1001 and we get a smiley face with 1001 back. Now, on the other hand, the reason why we had the generic u is that we could have an incrementer that is a maybe visitor from int to int. In this case, we return just 0 because there was nothing to increment, and in this case, we return value plus 1. Okay? This is not the same visitor because now it visits an integer into and produces an integer as a result. Whereas the first one produces a string as a result of the visit of the integer. And if you say new ink, then we get another result. But the function visit, mind you, is always the same.
Meneer,
Yes.
ik vraag het even terug naar boven.
Yes, I can.
U zult daar klikje in staan toch? Boven, naast
Yes.
mijn klik.
This is the
Kan
type.
je niet bij die ensemble string returnen?
No,
Waarom niet?
because this is not Python or JavaScript. If you say that it's going to return an integer, it has to be either an integer or something that can be converted to an integer.
Oké.
Okay?
Dus standaard tweede als je komma doet en dat is altijd returnwaarde.
No, it's just because in this definition here,
Ja.
I put the u, the second parameter,
Ja.
and I said that u is what on none and on sum would return. So, if we go back to the main visitor and saying here, this is the u, so on none has to use the string provided here. Notice that if I select this, can you see that the strings become gray? I'll do it again. Oop. They become gray. Because this is saying that the strings on line 41 and 46 actually come from the declaration on line 39. Yes?
Maar meneer,
Wait a second. oh, this one, the integer is this one here. Got it?
Kijk meneer, kunt u niet derde ding zetten? Gewoon derde generic van numeric boolean erbij. Kan dat?
Like this?
Ja.
No,
Waarom niet?
because
Wat is gelimiteerd aan 2?
because I declared it here. It should.
En als je daar ook een letter erbij gooit, en dan boolean maakt.
But then I'm not using it anywhere, so I could force it to be boolean. So it's fine. So it's fine, but it doesn't make much sense. So you're just gonna, I'm breaking everything, but yeah, you can add a medium of those. It's your choice. But in this case, I
Ja,
don't.
loose koppeling nou, zo van één ding niks werkt.
What?
U zegt net loose koppeling. U verandert één ding, nu werkt niks meer.
Yes, because this is the coupling interface. If you break the interface, I mean, that's the door handle. If you remove the door handle or turn it around, then yeah, and you try to open it from the left and somewhere else, then it doesn't work. But the type definitions and the method signatures are the only place where you can't have, in a language like Java or C#, where you can't have further loose coupling. If you want to have that, you have to move into metaprogramming. Which,
Maar dus voor alle duidelijkheid, je kan meerdere dingen zetten. Die,
Yes.
types.
but every time you use them, you have to provide one for every letter that you put in the declaration. Now, visiting can be simplified with lambdas. It seems like a counterintuitive sentence for some. How could lambdas make something simpler? But actually it is possible. Because actually the visitor is just a way to carry what things? The visitor carries two things. What are they?
And none, and some.
On none and on some. So why do we need an interface? We can redefine inside the option, which is maybe in our case, the visit method to accept one function on none and one function on some. Yes? Now, the implementation of none in visit will simply call on none. The implementation of some will simply call on some with value. That's it. Now, we don't need the visitor, we don't need anything. We can just directly give the lambdas. So if we go back to our implementation, I'm going to rename this to visit fugly.
Camera staat aan, hè?
Sorry,
Camera staat aan.
I know, but yes. Also, I find this implementation unpretty, so. And then we have the proper visit, which takes us in a function that returns a u, which we call on none, a function from t to u, which is on sum. Then we have to provide the implementations. What is the visit going to return? Quickly.
On none.
Thank you. On none. And in the case of sum,
On some.
With the value.
with value. Yes. Return on sum with this dot. Yeah. At this point, instead of doing this, which is a bit ugly, and it requires also an implementation of inc, which is some 11 lines of code, what we can do is console a write line. In case of none, the myInt.visit. The first thing we have to do is the function on none, which takes no parameters, and in this case it's going to return 0. And the second one takes the value and returns value plus 1. And now he's happy. So 11 lines of implementation of an interface have become 2 lines, and if you really want to reduce lines, you can just do it like this. Which will be acceptable because it's still short enough. But this is pretty clear. And we could do also the string conversion, which would be as simple, because here we had to put the set face, and here we had to put the smiley followed by the value to string. So all of this code here just disappears. Just like that. Now this works exactly as you would expect. So if I put 100, then we get the smiley 100 and 101. And if we put something that's making sense, I simply get a set of smiley and a 0. Now, because things can actually repeat themselves can be nested within each other, the visit here, instead of returning 0, which doesn't make much sense, might return none. And the visit here might return new sum of int of value plus 1. So that if we had none, we just keep none, right? It kind of makes sense. And at this point, then we have to specify that we're returning here. Whoa! Oh, it was maybe. Yes. Then this returns a maybe, and this maybe we can visit again with print. If I put the number 100 in the console, what's going to happen now? Sorry? With a smile. And if I put, so 100, 101 with smile. And if I put lol good, what do we get? Get a sad face. This is a pipeline for verifying the correctness of inputs, which cannot go wrong. In the sense that compiler will force you to better match on your types. Now, something else. But suppose you find an application written by someone that learned how to program in the 90s and really does pretend that the world is still dominated by Java in the 90s. So everything happens through the interface of the visit fugly method. We can build an interface, an implementation of a class which doesn't really do anything. We can build the implementation of the visitor so that it accepts 2 lambdas and does the work of the visitor interface, but actually codes the lambdas. So, and this is a completely, oh wait a second, yeah, is it still recording?
Yeah, 6 minutes left, so I'm gonna get a new SD card.
And we are going to take a break now. Well, stop it. Stop it? Stop it? Yeah. Stop it.
Vond niet aankomen.
Meneer, heeft u al de cijfers van de herkomst?
Nee. Die niet.
Meneer, wij over het ding heeft cijfers. Dat is die mondeling meneer van les 3. Ja. Hoeveel mensen hebben al cijfers? Ik weet niet wat gelijk. Dat doe ik echt niet. Je vraagt een soort van... Kijk zo, ik krijg niks tegen. Dat jij voldoende voor je melk wordt.
Ja. Guys! Guys! We're starting again. Hello, hello, hello. Teacher speaking. Laptop on. Yes. So, what we're going to do now is suppose we don't have visit, the pretty one, we have only visit fugly from the 90s as a recurring nightmare. Now, what we're going to do is we're going to build an adapter that takes 2 lambdas and implements this. First of all, what do you think it's going to look like? Sorry? No, not really. It's even stupider. Look, we have 2 lambdas on none and on some, and we want to implement the interface, maybe visitor. No ideas?
No.
Now, class lambda visitor tu, because it has to be generic. It's a maybe visitor of tu, so we're not even saying anything about t and u. Then we have a function that only returns u, which we call underscore on none. Then we have a function from t to u, which we call underscore on sum. Then we need a constructor, public lambda visitor, takes on none and on sum, and initializes the internal fields. So this on none is on none, this on sum is on sum. Yes? Following?
Could you scroll down a bit? So,
Yes? I can't score more than that. Oh, you want it higher up?
yes.
Sorry, I didn't understand. Got it? We just have 2 functions, on none and on sum. And these functions look suspiciously like the methods we have to implement. Now, what is on none going to do, the method?
this
return this
or none.
on none. And then, what is on sum going to do?
I don't have
With an exception.
It's simply going to call on sum with the value given. So, what does this lambda visitor actually do? Does it do anything specific?
Matches and calls a function.
It just calls the appropriate func. And that's literally all it does, right? It's not doing anything besides forwarding when we say, so it's actually a way to have two lambda functions that stay together and pretend to be a lambda visitor. So you have a lambda visitor, so no scary lambdas. But then, you call the lambda visitor and you say, yo, lambda visitor, on none, and he calls the lambda function underneath. If you call on sum, he calls the lambda function underneath. So this is a visitor, but actually, as a visitor, it's calling on none and on sum. This means that without having the prettier visit, suppose we only had visit fugly, then these are not acceptable, but we can build a new lambda visitor, which takes, what have I done? A new lambda visitor, which takes the two lambdas, it's a visitor of int and option, and maybe of int, yes, yes. And here we can do visit fugly again, and here we give a lambda visitor of int into, of int into string, which takes the two lambdas.
Meneer,
Yes.
hoe komt dat de imperative manier korter is dan de functie, of langer dan de functionele manier?
That's always so.
Waarom is dat zo? Wat ligt daarachter? Hoe komt dat?
I have
Dat is de theorie, weet je?
it's better abstraction.
Beter abstractie.
Better abstraction. So it means that you can combine things faster with less intermediaries.
Okay.
So it's like having Legos or having pieces of things where you, so with Legos are good abstractions because in each piece of Legos you can typically plug together automatically. Now, if you have something where you need screws and glue, etc., then you need the screws and the glue. Okay? Understood? And the lambda visitor, so what is the lambda visitor doing? It's adapting the functions that the lambdas that we want to give into the class that visit fugly is expecting. So it's bridging two separate words. Have you ever gone abroad to a place which with different electrical adapters, electrical plugs, where you need the adapter?
Yeah.
You know, this is exactly the same thing. So you have these that are the normal electrical plugs of Europe, and you have the weird three-way thingy, and the visit fugly accepts the three thingy, and this thing here takes the two and puts them here, and it gives you the empty one, which goes in the last one. Got it? So, the samples can be found online in Git. For samples, here paper moving. So go on Git to see this. What we've seen today is an instance of the visitor design pattern. We've also seen the null object, that's the option itself. And we've seen a first simple instance of adapter. But now we generalize the visitor design pattern. Now, the visitor design pattern in general can be used whenever we want to recover lost type information of from a general instance back to specifics. And the recovery is based on the actual activation of one of a bunch of options available. The options available are things like on sum or on none. And every concrete instance will activate the right one. It will activate on sum or on none. Sum will activate on sum, none will activate on none. So given a bunch of classes, C1 through Cn, you know why I call them C1 through Cn?
Mm-hmm.
Why?
Class.
Classes. Yes? So C of class. And they have n of those, so C1 through Cn. Okay? So some might say, yeah, this is mathematics, it's the letters. No, they're just classes C1 through Cn. It's shortened than class 1 through Cn. They will implement a common interface I. You know why I?
Interface.
I can't keep it here, man. Good. And every class has a bunch of fields. F1 through Fny.
Nou, maar dat is functie. Hey. Oké, method. Maar waarom hebben we geen n dan?
Because they're fields. Now, we add I method visit that returns a result of a generic type U. A generic type U, because we don't know and we don't want to.
It's getting late.
Your hat is not as pretty as your face. Yeah, turn around. I don't want to see your back and your head. Oh. Thanks. It's weird. Look at the hat. I don't find it pretty. Sorry. I find you neutral just as a student. It wasn't meant as a disparaging or encouraging comment. Now, visit will be common all classes implementing I, and it will pick, based on the concrete shape of the class, the right option between the ones given. So, and since we do not know what the visit will result in, does it return a string, does it return a beacon, does it return an option, does it return an int, etc., then we use the generic type U, which is what we return as the result of the visit. Now the interface, and this is the most important bit, is the interface I has the visit method that takes a bunch of functions on C1, which will be called when I has been implemented by
C1.
C1. And it returns a U and takes as input all the fields of C1. Generic example on C1 was on none. And what were the fields? No, for on none.
Oh, no.
No fields. So this was empty. We only returned U. The last one was on sum. And what fields did we have? T. This is just a T.
Yeah.
Just a tab, which was the value. Okay? Then class C1 implements I, has the fields, we have the visit method, we get all the on C1, etc. Which one do we call? And return, we return on C1 with the fields. Notice though, that as we implement visitor, we are not required to give all the fields here. We might give only some fields. We can decide which fields we make visible. Because this is effectively making a bunch of fields visible. So we might not give all of them, we might only give some of the fields because we decide those fields are the only ones that we want to show to the outer world. When we have an instance of type I, the interface, then to see what's inside it, we visit. So we say I.visit and we give here all the pieces of code that will be effectively executed when I was implemented by C1, when I was implemented by C2, etc., and when I was implemented by Cn. This is a switch on steroids, or an if then else on steroids, because it is an if then else which can have n ways.
Could you argue that any piece of software is a switch on steroids?
No, you cannot, because a recursive function is switch on steroids.
Any 90s program?
But this here is also, if you want, an if on steroids, because instead of the if connecting with a condition, two things, the condition is this.
Nog één keer meneer, dan komt de zon.
Yeah. So, this is the condition and these are all the cases. And actually, before we go ahead, how much time do we have left? 20 minutes, yeah, that's plenty. Look, we can also do something like this. Interface. Boolean is not good software practice, by the way, which has a method visit, which takes as input a function to U, which we call onTrue, and a function to U, which we call onFalse. Then we define class true, which implements Boolean. And what are we going to call here?
Leave ze.
Quickly.
Until.
OnTrue. And then we define class false, which is boolean. And here we call it on false. Okay? And now, suppose we have true or false. So boolean b is equal to true, but this would come from input or whatever. Then we can do console.writeLine b.visit. Then this is the true case. I was true. And this is the false case. I was false. Yes? So actually, with a mechanism like this, we can program
Meneer,
a lot of the internal data types. Yes?
waarvoor staan die haakjes?
These ones?
Ja.
That's because it's a function which takes no parameters.
Oké.
If you had a bunch of parameters, you would put them like this.
Ja, maar hoe kan je het gewoon zo leeg laten zonder haakjes?
Nope.
It's a string.
Because otherwise it's just a string. Exactly. Now, UML. You want to see the UML? Then it's online on GitHub. If you want
Meneer, schep UML, jongen, je pakt het.
Oh yeah, you have a 5.4 here in UML. So that's not funny. That's not funny. Nobody laughed. It's a 5.4. So close and yet so far away. Anyway, so final considerations. The visitor pattern provides us with a mechanism to safely manipulate polymorph. Guys, provide the visitor pattern gives us a mechanism to safely manipulate polymorphic instances. The mechanism is quite transparent because using it with visit, if you look at usages of visit, like this one, this is not that distant from an if. In the sense of, in terms of lines of code that you would write, an if would be 3 lines of code, and this is actually an if. Do you realize that this is an if?
Word discriminate union.
This is a discriminating union, yes. A lot of things are discriminating unions. The mechanism is quite transparent. It's safe because the compiler, if you don't give one of the functions, the compiler is going to complain and say, "Oh, you didn't give me one of the functions," which are needed because you have 3 parameters for the visit function, and it wants 3. You have 2, it wants 2, etc. And the instance itself selects the proper implementation among the input arguments, but this is without any complexity because you know that the true class will select the onTrue option. The false class will select onFalse. Sum will select onSum. Cat will select onCat. So the implementation is very low overhead for the programmer. So you move the complexity of making the choice into the class. That complexity has disappeared now, and you're done. So the implementation of the visitor is simple. Usage of the visitor is simple. And so some complexity that otherwise will be mixed everywhere just disappears. Do you like it when complexity disappears? Yes. Good, that's the right attitude.
So are you using...
What the fuck? I can't be there, I have a lecture.
Are you using sprite sheets for the letter?
Meneer,
Oh, that's cool.
Sir, are you using sprite sheets from football?
Sprite sheets?
Yeah, they are
They
not
are.
rendered properly.
The R's are...
I have no idea whatsoever what he's doing. But it's a decision of LaTeX, not mine. Now, what we've seen so far is the introduction to design pattern and the visitor pattern. Now we're going to see the iterator, which actually extends visitor on option to lists, so it makes it essentially bigger. Then extending behaviors, decorator over the iterator. So this is going to allow us to build more complex iterators based on iterators. Then factory, which abstracts away the code of the new function, because new is very monolithic. So we're going to abstract that away with factories. And finally, we just relax for a bit in the last lecture by seeing the adapter that we have seen. We will have seen here, here, and here. In conclusion, our goal is to reduce coupling. And unmanaged interactions might introduce bugs. And we want interfaces, we want to use interfaces to control these interactions, which when unmanaged might cause problems. There's a bunch of software engineering techniques that span a series of more general, more abstract design tools, which are called design patterns, that actually have been developed to achieve this low coupling by effectively using interfaces. And this is the topic of the course. Now, do you have any questions?
Ja.
I am not surprised.
Over die practicum.
Yes.
Krijgen we iets van jullie geleverd die we moeten aanvullen?
Yes.
Of moeten we van het scratch zelf maken?
Yes.
Welke yes?
First.
Oké. En dan nog één vraag. We hebben de les voorbij toch? Hoe komt het nu dat NVC weer hype is geworden?
Sorry?
NVC. Hoe komt dat dat het weer hype is geworden met? Vroeger NVC